So let's take some stuff from the first couple sections of Unit 4, just some factoring and zero product property stuff, and let's zip through this, and then, like I say, you go get back to work. I'm updating grades today. I probably won't get to your class until after school, so anything you do today will go in on your grades. What about this guy? So the greatest common factor, we're trying to find the greatest common factor. This is one where we've got numbers and x's and y's that looks like it's going to make it complicated, but it's really no big deal. Okay, so what are we going to do? What's our GCF here? Okay, there's going to be three parts to it. There's going to be a number part potentially, an x part, and a y part, right? So the biggest number that goes into all those is going to be a 7. Now, what about the x?
X squared.
Okay, x squared. How come? How come, Josh? How come?
Because the lowest is a square.
Okay, because the lowest is a squared, right? All the terms have an x. This guy's got an x to the 6th, but these two only have x squared. So they can only give away an x squared. I can only undistribute the smallest power of a variable that shows up in each term, right? So we're going to have a 7x squared. What about the y's?
Just a y.
Just a y, because that's all that this term has to give. Now, what if this term didn't even have a y?
Then nothing.
I couldn't do a y then, right? Okay? All right, very good. Okay, moving on. It says factor the expression completely. Okay, so, yeah, so I can't undistribute a variable, right? Because the last term does not have an x. So the greatest common factor, let's figure out what that's going to be. So a 2 goes into all those. Is the greatest common factor going to be positive or negative? It's going to be negative, isn't it? It's going to be negative because I've got a negative sign right there. So it's going to be negative 2. Okay, so but that's not what they're asking for. They want us to factor this. So then we've got to write this as the product of the greatest common factor, which is negative 2, times whatever's left over, right? So if I divide each of these by negative 2, what's left behind?
X squared.
So I'm going to get an x squared.
Minus 5x.
Good.
Minus 24.
Okay, so now, that's good. We got a greatest common factor out of there. Can we go further?
No, actually, yeah, we shove the 2 out front.
We have the 2 out front. You're right. So no matter what, we've got the 2 out front. That's going to stay there. But the question, I guess, is can this break apart?
Yeah.
Okay, I mean, we could try. Either it's going to work or it's not. But that's an x squared, right? So it might break apart. If it does, what's going to have to go there and there? X. And so then the question just becomes, do the magic numbers exist? If they do, we can factor it. If they don't, we can't, right? So are there magic numbers that multiply to negative 24 and add to negative 5? Negative 8 and positive 3. So it does break apart. We found the magic numbers. Okay, and that is our answer. That's completely factored. We can't break it apart any further, can we? Look, I'm down to x's now, right? And I already took out the greatest common factor, so I'm done. Questions?
No.
Okay. Factor this one completely. Okay, can I factor out a greatest common factor this time? No, there isn't one, right? So I'm stuck with this the way it is. So this is a slip and slide one, right? So what's step 1 going to be for slip and slide? This is kind of side work, right? Okay, so I slip A over and multiply by C, right? So that's going to give me x squared plus x minus 90. Jaylene, what's next? What's next? After I slip the A over, now what do I do with this? Factor it. Well, there is no greatest common factor, but I'm going to try to factor it, right? Try to factor this regularly. Now that's an x squared, so what would have to go there and there? X. So then the question becomes, do we have those magic numbers? Are there magic numbers that multiply to negative 90
And a
and
negative
add to
9.
1?
And a negative 9.
Negative 9 and
10.
10, there you go. Okay, so plus 10 minus 9, okay? What's up next on this one? Divide by 15, there we go. So step 3, whatever's out front, right, whatever we slipped in step 1, we're gonna divide the magic numbers by that and reduce. So Autumn, what does that give us if I reduce them? X plus 2/3, good. And X minus
3/5.
3/5, good. And then, so the last step, slide. Slide any denominators that still exist up in front of the X. And so we get 3x plus 2 times 5x minus 3. That's my answer. Okay, how could I check to see if I did it right? It's easy to do. Yeah, just FOIL it out and see, right? If I FOIL this out, let's just see if it looks like it's gonna work. If I were to FOIL this out, 3x times 5x is gonna give me, what do you know? I get 15x squared, don't I? I'm gonna get minus 9x plus 10x plus x, right? And then finally, if I distribute the 2, I get a negative 6, so it works. We know we got it right. Okay, what about this? Completely factor the polynomial. So what do we always want to do first? Greatest common factor. Dominic, can you see a greatest common factor there? This is a little bit of a tough one. Yeah, it's gonna be bigger than 3. Okay, now let's think about this one. We can be smart about this. There's a little trick we can play here. So you know 3 goes in, how come? Okay, it goes into, if I add the digits up, right, it goes into 6 and it goes into 15. Okay, does 9 go into these? No, it doesn't, because the digits don't add up to something divisible by 9, but 3 does. What's another number that goes into both of those? Say it again.
6.
And how'd you get 6?
I divided them by 6.
Okay, so you found that. So that's good. So you already knew that. 3 goes into both of these, and they're both even, aren't they? So we know 2 goes into both of them. Now think about the consequences of that. If they're both divisible by 3, and they're both divisible by 2, what are they divisible by? 2 times 3, right? They gotta both be divisible by 6 then. See how that works? That's kind of tricky, huh? So we know 6 goes into both of those. So what's my greatest common factor?
Negative 6.
-6, there we go. It's gotta be negative, because I've got a negative out front in with my leading term, right? Okay, so then the question is, what's left behind if, what's left behind if we factor out a -6, right? So this is equal to -6 times what?
5.
If I divide this by -6, what do I get? Okay, good, the negatives cancel, and I'm gonna get a 25 x squared, right? Everybody agree?
Yeah.
Okay, what if I divide this guy by -6? -16. Okay, so far so good. Okay, can we go any further though? That's the next question. We factored out a -6. Can we break the black factor up into pieces? Okay, what do you think? We got to be very strategic about this. Joseph, what can you tell me about this factor right here? If I'm going to break that apart, how am I going to go about doing that? Say it again. Okay. We got any ideas? What do you think? A squared minus B squared. Let's get phones away, please. How am I gonna do that? Now, this isn't one where, it's only a binomial, right? This is not a hard one. This isn't one where I've gotta find slip and slide or anything crazy like that. All I've gotta do, if it's a binomial, and I've got an x squared term minus a number, there's only one possible way this is gonna factor. What's that gonna be? It's gonna be that difference of squares one, right? Okay, Marcus, what do you got going there for? Oh, calculate, oh, never mind, okay. So, never mind, now I don't wanna interrupt that, yes, you're probably doing this good math there. So, the only way this could work is a squared minus b squared, right? That's the only way this thing could work, is if we can fit that pattern. What is that pattern? What's my difference of squares pattern? A squared minus b squared. But how does that pattern work? A squared minus b squared always breaks apart into, those are both a's and b's, right? What do I do? A minus b and a plus b, either order, right? So that's my difference of squares pattern. So then the question is, can I take everything in here, right? So this is equal to, I've already got my -6 outside, I got that, and I've got my black parentheses. Can I turn what's inside, can I turn all that stuff into an a squared minus a b squared pattern? Okay, what's my a? 5x, everybody agree? If I square 5x, that's going to give me 25x squared, right? What's b? 4. If I square 4, I'm going to get my 16. Okay, so it does fit the pattern, so then we know how it's going to break apart, right? It's got to break apart into my difference of squares pattern. So what's that going to be? What's that going to be? Jaylene, what's that going to be? What's my pattern here? If that's my A and that's my B, how's that going to break apart? Say it again. 5x plus 4. Good. So that's going to be this one, isn't it? Good. So we're going to get 5x plus 4, and that's that part of the pattern. What's the other one? There you go, 5x minus 4, and that's going to be that part of the pattern, and we're done. Good job. Okay, make sense? All right. Okay, how about this one? Completely factor this polynomial. What do we always want to do first? Sound like a broken record? Greatest common factor. Molly, what's the greatest common factor here? -2. Very good. Okay, so we're going to get -2 times what's going to be left over. If I divide each of those by -2, what am I going to get? What's -2x squared divided by -2? X squared. -8 divided by -2. Okay? So we got the greatest common factor out. Can I go any further? Which pattern would I use?
Difference of squares.
But that's not a difference. That's a plus sign. So it'd be the sum of squares pattern. Yeah, remind me what that one is. What's a squared plus b squared break into?
A squared plus b squared.
A squared plus b squared. There's no pattern. It doesn't break apart. There's nothing I can do. So yeah, this looks like x squared plus 2 squared, but big deal. We can't do anything with it, right? You can't break it apart. So this one is done. That's my answer. Okay? Okay, very simple. This is on there just to remind you what our strategy is. If it says find the zeros of a function, how do I find the zeros of a function? What is that telling me to do? Find the zeros. Okay, I'm setting it equal to 0 and finding the x-intercepts by using the zero product property, right? This one's, the hard work's already done. It's already factored. There's not much left to do. When could the left factor times the right factor equal 0? What's the only way it could work? If, yeah, either this one is 0 or that one is 0, right? The only way it could work. So we just figure out what are the values of x that would make that happen. So we could set 2x plus 1 equal to 0, and what's the answer here? -1/2. Or we set 2x minus 7 equal to 0, and we get x equals what? Yeah, we add 7 and divide by 2 to solve for x, right? So those are my two solutions. Okay, those are the zeros. Okay, this one's a little bit tougher because this time they didn't do the work for us, but it's the same problem, right? They're asking us to find the zeros, find all real zeros, so I'm just gonna set this thing equal to 0, and I've got to factor it first, and then I'll use the zero product property. Okay, how does this factor? I get x minus 7 and x minus 7, right? And that's equal to 0, so what are the solutions? Positive 7 both times, right? And I could even write it this way if I wanted to. I could write it as x minus 7 squared equals 0. Either way, it doesn't matter. I only get one solution, 7. Okay? Usually I'll get 2, but that time I got 1. Okay, solving this. We're almost done here. Solving this, now if I want to solve this, this just adds one additional step, right? To solve this thing, what do I have to do first? Okay, so good, I'm going to take all this stuff and move it to the other side, and the reason is because I want to set it all equal to 0. Okay, so if we do that, if I move everything over to the other side, I'm going to get 2x squared minus 12, or sorry, plus 12x, right? I'm adding 6x to 6x. And then I get minus 28 minus another 26 is minus 54 equals 0. Okay, now what? Greatest common factor. What can I undistribute? 2. I could take a 2 out. What's left behind if I undistribute a 2? X squared plus 6x minus 27. Okay, and then can I break that apart?
Yes.
Yeah, I can. Those are x's. What magic numbers multiply to negative 27 and add to 6? 9 and negative 3. Good. Okay, so now let's apply the zero product property. So we got to set each factor equal to 0 and solve. Well, when does 2 equal 0? Never. Right? That one we don't care about. Right? That one's not giving us a solution, is it? In fact, I could divide both sides by 2 and just get rid of that if I wanted. Right? It's not going to change the answers, is it? So what's that solution going to be? So I get negative 9 or x equals 3. Okay? And we're done. Yeah, that's good for today. You work. Flip around, face back, and get going. Yes, you may.